So a little bit about us. We work for Fishnet Security, but we're not salespeople, so you really don't have to worry about that portion of it. I'm a principal consultant on the AppSec team. I also am an associate professor of software engineering at the University of Advancing Technology, so they have a booth over there in the vendor area if you feel like talking to them. And even though we didn't change the slides, that's actually J-Rock, not Justin Engler. We went through our entire team and gave each other hip-hop names, so that's J-Rock.
Okay, Nate Dogg.
And I'm Nate Dogg, yeah.
I'm Seth. I'm also a principal consultant at Fishnet.
And I'm Greg. I'm a senior security consultant at Fishnet as well.
I'm Justin. I'm a regular consultant at Fishnet Security.
So kind of what our talk is about here is we're going to provide a little bit of an overview of problems with current testing tools that, that people may or may not be aware of. So kind of our modern landscape is that we end up with people who may be in a QA or security testing role who may have come from a different background, that like they may not have had development experience. So when they run into problems or when they run into technologies they may or may not understand, they might not find vulnerabilities that are fairly easy to find. And some of that is a problem on the tools perspective, like not being able to handle modern web applications. So we'll go through some of the current workarounds and how that, how people are handling those. We'll go through a little bit of proposed solutions, like how those can be fixed. And then we wrote a tool to start addressing some of these issues. So we'll go into, we'll skip some of the stuff and get right to the demos and show you the tool. So what we aren't going to do, which this is kind of a lie, so we aren't going to beat up on any particular vendor. So that's kind of sort of not true, but we're gonna try to keep.
We didn't say tools. We just said vendor.
Yeah, it said vendor. Yes. We also currently can't solve every single problem that we outline, but we're working on it, and we're definitely not going to sell you a solution. So our goals for this is, one, to raise awareness for people who actually test applications. We want to put focus back on the tester and not so much on the tool, and that's what our tool allows you to do. I know that sounds kind of weird, like we're giving you a tool so that you don't have to use tools. So it sounds kind of strange, but you'll get it by the end of the talk, I promise. If not, you can punch me in the face afterwards. And also to get you to submit bug reports for Raft. I remember a couple times when some tools came out, I don't want you guys to do what I did, so I would download the tool and give it a try, and then think something wouldn't work, and I'm like, this sucks, I'm not going to look at it anymore. So don't do what I've done in the past. I realize I'm not being a good advocate of that, but we will fix something, and we will take feature requests and try to work things into the tool. So a little bit of clarification. Throughout the talk, we use terms fully automated and semi-automated. And sometimes we use those interchangeably, so that causes some confusion, and we're going to continue to be confusing about that, so sorry. So this slide's going to try to explain what we mean. So if you think of a fully automated testing tool, like your enterprise application testing tools, those are like the Mac 10 on the right-hand side, right? So basically what you're doing is you're loading up a bunch of bullets and you're just spraying them in a current. Anybody who's ever shot a Mac 10 knows that you can't hit anything with it. They might as well not even have any sights on it. You just point it in the general direction and you put holes and stuff. Not always the best solution. So semi-automated testing, or how it should be, which is what you'd think of sending data to something like running through a bunch of different test cases. That's more like the semi-automatic sniper rifle. So you're honing in on a problem, and you're really trying to focus on that problem and find vulnerabilities based on a specific set of test cases. And that's mostly what we're talking about during this this talk. Is we're talking about the left-hand side. We're talking about the sniper rifle.
Okay, so I'm going to kind of talk a little bit about the current solutions that exist out there. I'm not sure how well you guys can hear me. Basically, we test for a living, right? We're looking at web applications, and we've kind of figured out that they all fall down in some way or another. I mean, you get the fully automated tools where you click the start button and it's supposed to find every vulnerability under the sun, and I end up spending 2 to 3 days configuring the thing, and it comes back and it tells me there's, SSL is inconfigured or misconfigured or some shit like that. So the automated tools fall down. I mean, there's the fully automated ones, the semi-automated ones. They have session and state problems. You've got scanners that'll run and they pull what you did. And the next time that you go to the site and have the tool run, it's out of state and it can't figure out that it's out of state. So you've got hundreds or thousands of requests that are coming back in the tool, or that the tool is making to the website, and they just aren't valid because they're all returning 302 redirects or something like that. They have problems with these complicated applications. The modern technologies we already talked about, CSRF tokens, rich internet applications, web services. The tools just don't understand them very well. Furthermore, all this data that is collected is in disparate locations, right? You've got your proxy that you're using while you're testing. You've got the full-blown app scan or web inspect. Sorry, I probably wasn't supposed to mention that. But the fully commercial scanners, I mean, getting data out of those tools can be just one huge pain in the ass. As you go further, you've got all this data that you've collected that there's no analysis that's run on it after the fact, right? You've got a single request response. The scanner goes in, it makes its assumptions about what's happened, and then it basically discards that data. Right? There should be some sort of analysis that goes on after the fact. As testers, we need more interaction, not abstraction, right? We need to be able to understand the application in order to break the application or in order to find the vulnerabilities. And if it's not, I mean, if the tool is basically the point and click tool, you don't understand what it's doing behind the scenes. All the vulnerabilities that I find typically are because I'm in the application, I'm actually looking at the requests and the responses on a low level, not at the level that is being presented to me by the tool itself. Furthermore, we miss portions of the application. If you think about the mobile applications that exist in the space that's out there now, when your iPhone makes a request, you get a different application than you do when you're using your Firefox web browser. If the tool doesn't understand that, hey, it needs to fuzz the accept header or the user agent header to actually get into portions of the application, you're going to miss maybe 50% of the application as developed by the developers. And there's some risk. We could go on forever. If you really want to know about the problems, we really beat up within the white paper that we presented.
Can anybody tell, anybody who tests web applications, so say you have an automated testing tool, can anybody see from the screenshot why it might have a problem? There you go. It says sign out. A lot of automated testing tools look for a regular expression to tell whether it's in state or out of state. So the application is clearly asking the user to authenticate, yet it says sign out, like they're already logged in. So a lot of tools will continue to send their tests and fail based on that.
And then you've got things like this risk-based login that we're talking about at the beginning, financial applications. Depending on where you're coming from, if it's a new browser that hasn't seen before, they're going to ask you for more layers of authentication. The first time you step through it with your tool, it may, ask 2 or 3 different questions, and it'll be different the next time that you hit the application. So these tools are just, they're basically killing us when it comes to application testing. There's simple features we're missing: request times, authorization checks, storage locations, the new HTML5 spec, Flash objects, things like that. Especially these tools that were built in 2001, 2002, they don't understand any of that new technology.
So now that we've talked about why the existing tools can't do a good job on the whole picture, we're left with trying to figure out at the end of the day when I have to do an assessment, what am I going to do? So even though a lot of tools don't handle the whole picture, there's some that can handle pieces. So we run a bunch of separate tools that do little pieces. And a lot of them don't have any analysis of their own. Sometimes we'll write our own custom scripts to do something custom to generate a whole bunch of requests. But then we don't have any way to analyze what we just did. And not only do we not have the way to analyze just the one thing from one tool, we've got all this stuff from all these different data formats, and we don't have any way to get them all in one spot and then look for commonalities. Another problem with doing it this way is that most of these tools, even when they do have analysis, you can only do it on the stuff you just ran. If you've got data from a bunch of tools from last year and now some new type of vulnerability came out and you want to check, hey, do I have that in any of my stuff? You're going to have to scan everything again. You can't just take the results that you had and run the analysis. So instead, you could try testing manually, but when you look at the scope of the assessments, at least that we get, there's not really any chance that you would be able to get anything meaningful done by manually clicking things and manually looking at the responses. We've got, thousands of pages to look at in the course of 2 weeks. You're not going to get it done. You need to have something that helps you reduce that burden. So just manually doing it isn't going to work. If you've got a crazy tool that almost does what you need, sometimes you can modify something to do what it wasn't supposed to do, but even that can be painful, and you're spending time writing scripts when you should be spending time testing the program that you're supposed to test.
Has anyone in here ever had to use like Windmill or Selenium to do a security test? Anybody? Couple people.
Hands.
Okay, so that's kind of what we're talking about. Like, Windmill and Selenium are more or less QA tools. They're not really made to find security vulnerabilities. So you might be looking for something specific, like let's say you modified and you had some Selenium scripts and you were looking for SQL injection. Well, you're kind of focused on SQL injection, but you might miss a whole slew of vulnerabilities in other data in the same request that could be easily found if there was proper analysis done on it.
So the other problem is many tools were fine when they were first written so that you could, present at DEFCON a couple of years ago, but they've never really been kept up to date, or they don't adapt. And so just like our picture, you need to stay up to date with the times or you will become useless. I would argue.
I don't think she's ever been useful,
Yeah,
but it was just a funny picture.
So anybody here use NIC2 on a regular basis for doing web application testing? Raise your hand, please. We can get some kind of count. Okay. And how about Dirbuster? A couple more hands. All right. Okay, so I'd say that was maybe 10%. Yeah.
So if people haven't figured it out yet, NIC2 is just a piece of crap. If you actually look at what it is, it's just a list of web request URLs that get sent, and it has some pattern matching that comes back. There's no intelligence in it at all. I mean, about the only thing it's valuable for is testing very broken WAFs. And Dirbuster, we're going to talk a little bit more about Dirbuster. So those word lists that you guys are using in your Dirbuster tests, or if you're using Dirbuster or if you're importing them into another tool, those haven't been updated since 2007. And if people haven't noticed, the web has moved on since then. And there's a lot of common words that we see all the time that aren't in those lists. So there's a couple reasons for this. When those lists were first generated, they were generated by going out to websites and spidering the website, seeing what directories existed, and pulling words down. Well, if you think about that, you're interested in parts of the website that don't exist, not the parts that do. So if you're just depending on values that come back, you're going to be missing all the stuff that you think you should find but aren't. And there's a lot of bad words in there, so you're wasting time, because search engine optimizers do keyword stuffing, so you're going to end up with all these strange words that are completely useless. So here are some common words that we see in our assessments on web servers that aren't in the small and medium list. I mean, ASP.NET, ASP.NET Client, that's pretty important. The VTI directories, there's good information that can be pulled from that. So that's just something to be aware of. I mean, these are common things that are missing. So if you're depending on these tools and not actually looking at what they're doing, you have these big blind spots. And this is kind of, we were reviewing the Dirbuster list and we were like, what the hell is this? Jeremiah Grossman, I mean, I'm sure people know Jeremiah, either through his reputation or at events like this. When was the last time you found the Jeremiah Grossman directory on your web server? Really? That doesn't make any sense. Why are you...
Maybe he just stopped by to say hello.
Yeah.
But the thing I love is that the ASP.NET Underbar client isn't in there, but Jeremiah Grossman is. Yeah.
Yeah, it's like, really? Does nobody look at this stuff? So that led us to say, well, we need to generate our own word lists. how do you approach this problem? And we said, well, let's think about some way that we could go out and find words that people are telling us not to look for. And if you're familiar with the robots.txt exclusion standard, basically webmasters go through and they mark parts of the site that they don't want Google spidering. You know, maybe there's sensitive data there, or maybe it's underlying web application components. So those are the kind of things that when we're doing an assessment we're very interested in. So we went through and we pulled down the robots.txt file from a lot of sites. We combined the Alexa and QuantTask Top Million site and pulled down about 1.7 million. We made about 1.7 million requests and found 350,000 unique files. And we went through and we generated word lists based on how prevalent certain words were. So it's kind of like we crowdsourced what people are telling us not to look for. So we've been using those on our assessments, and we're seeing that we're getting better results back than when depending on the Dirbuster list. So those are out in our SVN on Google Code. You can pull them down. Right now they're just in a 7-zip file, so pull them down, look at them. You know, if you think they suck, there's probably some stuff in there that doesn't make any sense. You know, let us know, give us feedback.
So one of the things that I always like to say is that tools don't find vulnerabilities like people do. So tools should be there to assist in identification of vulnerabilities, not exactly point them out. So if you have a tool that's telling you something is vulnerable, the tester has to have the knowledge to look at that data and say, yep, that's an actual vulnerability, or it's not a vulnerability. So we decided that there's too many tools out there with absolutely no intelligence when it comes to the sort of fuzzing or fault injection testing of applications. So if you had like say you were testing for SQL injection and you have a good SQL injection list that you want to test with different values, with modern applications, a lot of times those fall down. So if you've right-clicked on your favorite tool and said send to insert semi-automated testing tool here, if there's a CSRF token that changes every single time the page is laid out, that means every single one of your tests is going to fail. It's going to come back and say, you know, yep, not vulnerable, or depending on the error message it may come back, you might be able to identify that. But that's a big problem. So, because often you can use, you know, automated tool, and it might not find an instance of SQL injection that was very easy to find if the person would have tried to test manually. But they're using these semi-automated testing tools, and it's failing, and they're assuming that they can move on to other tests. So a smart tool, a smart semi-automated testing tool should have several components. It should have session management, obviously, because we want to make sure that our tool is smart enough to stay in session. It should have sequence building and running. So if you have a difficult test case, you might need to run a sequence of events prior to sending your test case, and even a sequence of events after you've ran the test case. So for instance, you may need to run a sequence of events to log you in, run a test case, and then log out. There are crazy weird applications like that. A lot of international money transfer applications have weird functionality like that to try to make them more difficult, I guess. So security through obscurity. But any tool that can handle those three things can test them rather easily. Also content discovery and support for like modern technologies. So we all know that something new comes out, developers want to use it. It always takes testing tools time to catch up. So here's our tool. We're going to start talking about how we solve these problems and how you can use our tool to help you solve some of the same problems. So a little bit of history about RAFT. It was written, it stands for Response Analysis and Further Testing, which is actually on the next slide. I probably should have said that. But you're probably wondering why there's a big red raft in the center of the screen right now. So this tool was created because I was on an engagement and I had to write some custom scripts to test some functionality of a web application. And I got to thinking, there's this data I'm collecting and I'm looking for something specific. Quite simply, I wanted to be able to see the data, syntax highlighted, I wanted to be able to see the data rendered in some sort of web view, and I wanted to be able to parse out scripts and comments and all the general things. So I created a simple Qt interface that allowed me to do that. Of course, the tool today looks absolutely nothing like the beginnings of it. So
yeah, it used to be just basically a SQLite browser.
Yep, with focus towards web technology. So basically, it's not an inspection proxy. So that might throw you for a loop a little bit, but we decided to take a different route and kind of change that paradigm that everybody's used to. Because if you think about it, you're just chaining responses through another device or another application.
So that's really important because almost all of the workflow that you see on all the other tools is, well, you'll set up this inspection proxy, use whatever browser you want to go browse through the site, and then come back and look at the tool again. We decided to just cut out that middleman, and instead you can import data if you already have it, or you can just use the browser that we have ourselves. So we actually built WebKit right into the thing, so it works just like your Safari or your Chrome does, and it renders things the same way. So a lot of tools that have their own browsers, they often have something that's kind of not as full-featured or is just a little weird. This one is going to work just like you expect it to. We also, a big piece of this is we made a custom analyzer engine, so you can write whatever it is you want to find easily and then run it against all the stuff you have. It's all open source, it's Python and Qt, and it's designed for testers. This is not a fire and forget, click the button and your report is done tool. This is designed for someone who already knows how to test web apps, but they just need something to help out. So now we're going to have the demo. What you've all been waiting for.
Yeah, we got through like the boring technical stuff, so we'll see if we can get this going. All right, this is the user interface, and we're sorry about the screen resolution.
Screen resolution looks like crap.
Yeah, this has a little bit different workflow, like Nathan talked about. This started out as a way to look at data from other data sources. We have our own capture format that we have defined. It's an XML-based format, and what we have provided a DTD for you, and there's a urllib2 module for people to do Python that you can just plug it in as a processor, and it automatically generates this format. So we'll look at some data we've captured, and I just want to point out here, we're off the internet anyway, but there's an important thing that we discovered is when you're looking at rendered data from old assessments, you may have a limited time window for your testing, and you're not supposed to be interacting with the site. So we have this black hole network, so if you're looking at old response data, there's no traffic being sent out to the internet. But when you have captured data, if you have all the references, all the images, anything that was originally referenced, then the built-in rendering will pull that out of your capture data and display the web pages that originally existed. We have responses. Here, I'll zoom this in so you guys can see. We have the zoom feature, which is really handy. You can see the request, the response. I don't know if there's any scripts on this, but we pull them out. I'll find some with comments. Links, we pull out all the links. So you get a quick view of what all the references are. Any form values, you get those. And we kind of go through and parse out of the DOM and generate the list of forms. And then one of the really handy features, if you do a lot of assessments, especially with highly dynamic applications, you know that you have to do view source a lot, view generated source. So we have the generated source that we render the page and pull out of the DOM. And any of these references like links and forms that are dynamically added, those also get included here. So that's pretty handy. So that's imported data. We also support from the RAF format. We also support burp logs, burp state files. If you use Burp Pro, you know the saved state files. That's and the XML, saved XML, and WebScarab and Paris message log formats. We don't do their storage, but we're working on that because it's not a good interface. We also have our own built-in web browser, so you can go and pull up sites. Here, let me copy one here. I can just type that in.
Yeah, don't get into my porn.
Yeah, definitely. So we just have an instance of the broken web applications running locally here.
So this is a simplistic, I don't know why I'm bending over like that, that just looks strange. This is a simplistic view of our browser. It's made as a proof of concept, so in the future we're going to have...
Yeah, there is, the question we got the most is there is a back button, you just have to right click in the page to go back.
That's terribly intuitive.
Yeah.
We understand.
Yeah, we definitely have some UI. You know, we're not GUI designers, so we have some like UI inconsistencies. So you just have to work through those. But as close that, and if you if I scroll down here, we'll see that any requests that we've been making. Yeah, we have a zoomed in view. So those requests that we were just making are now being saved in our storage. We use SQLite in the back end, so those are just getting saved to a local storage database. Other interesting tools, we have a little search engine. You can go through and type in, like let's say you want to look for HTML comments. So this one will have some comments in there. And we offer a variety of search routines. There's a built-in differ. Let's see if I can find some pages that are similar. Oh, I'll just pick two that aren't. Just so you can see the differences. Yeah, this is like a really bad example, but with its syntax highlighted, it's using the built-in diff live in Python, if you're familiar with that. So it's based on word matching and not byte positions. We're going to cover some of these things like the analyzer, the requester, like simple tasks, like requesting a whole bunch of URLs that other, like going through and saying, well, copy my sitemap and re-request them with a different authentication sequence. That's like really tough to do in a lot of tools, but here we have it all templated out, and you just copy the URLs in here, pick a sequence, and rerun it. Our crawler is a little bit different. It has the traditional web spidering approach, but in addition to just pulling down and analyzing the raw HTML, it also renders anything, so highly dynamic web applications that, that are based on Ajax or some other rich client technology. We can go ahead and pull out any dynamically generated links and follow those. We generate mouse events, text events, submit forms, do clicking, all on dynamically generated basis. We have an encoder. Probably the most interesting thing was UTF-7, generating malformed UTF-7. There's a lot of WAFs out there that check for UTF-7 in cross-site scripting attacks, but they don't check for malformed versions, and web browsers are more than happy to render UTF-7 if it's malformed. We have a data bank. It's going to hook into both the spidering and any sort of sequence if you do replacement, dynamic data replacement. We'll cover that a little later. Sitemap. You get a view of the sites. Cookies. In addition to your traditional cookies, we also have offer views of flash cookies. So this is pretty interesting. Nathan cleaned all the porn off his machine, so all those flash cookies got deleted. Right now you can only view them, but we're going to give you the ability to edit them. That's really important, like if you're testing risk-based applications with risk-based logins that are storing data in those flash cookies, getting a good way to go in there and edit those values. And HTML5 local storage, I'll go through a little bit of a demo of that later. And that's about it for now. We're going to start covering some of the other interfaces.
J-Rock doesn't know how to use a Mac, so
sorry, guys.
I have to drive it for him.
So, yeah, as the regular consultant, I get all the boring slides too. So, we run on Mac, we run on Linux, we run on Windows. Mac works pretty well. Windows, you've got to do some compiling. I'm not going to go into the boring details. The easiest way to use this right now, if you have Backtrack 5, you have to do one apt-get install of QScintilla, and then just download our stuff, and it works. We've been trying to keep everything that we need packaged in with it. There's just a few things that we don't, but this is the list. It's up right now in Google Code. We will eventually have packages, so for those of you on Mac and Linux and Windows, it's easier for you to just download it and run it. And please, so how many of you are web application testers like us? Show of hands. Rough? Okay. How about functional testers of things that might use tools like this for security? And a couple more? Okay. So everyone
Who knows how to
raise their
write
hand-
documentation?
We need those
Sweet,
guys
man.
too.
You're on.
So all you guys that are testers, whether it's functional or application, your specialty is telling developers how much their software sucks. So we need your help in telling us bug reports on what goes wrong, and then hopefully some help on how to fix it too. But even if you just tell us what went wrong, that'd be great.
Yeah, you're probably going to want to wait like a week or two so we can get back from Vegas and fix some of the problems that we found while we've been out here. We're like 12th hour development, like running down, 10 minutes before we had to present writing code. So, that's the way it goes.
Yeah, we presented at Black Hat, and we didn't see the outside of our hotel room pretty much the whole time.
Okay, so now we're on to the analysis engine. Right? It's obviously in the title. This is a big portion of Raft. We wanted something that would actually analyze everything that we currently had, right? I don't want to have to spider the site again to figure out if there are comments that may, have some data that are interesting. Yeah, I can go back through the burp state or whatever, but it's, you always find yourself writing another manual tool to pull more data down. But if I've already got all that data, let's actually just analyze what's there. So our model here for analysis is something modular, right? We want to be able to, write one time and have it analyze all this data that we have. We want to be able to analyze sessions as a whole, not just single request responses. If the first request is different from the last request, but we made the same or the responses are different, but we made the same request, we want to know that and we want to know why. So we want to find what others ignore. We want to look at timings, like how long it takes a page to respond. We want to do some image analysis. If you guys have looked at Google Images lately, they now actually pull out EXIF data and will display where exactly an image was taken or what camera was used for it, that type of information. And that's not something you typically look at during an assessment, but it could be useful information, especially for a social engineering engagement, something along those lines. So the possibilities are really endless. These analyzers are extremely easy to write. Let me show you at least the demo, right? I guess we've got anal going on right now, but right now there's nothing in the analyzer. We haven't run the analysis or the analyzers yet, but we are looking at actually hooking some of the scanner and fuzzers into the analyzer, so it would kick off specific analyzers when we make a request and things like that. But currently we have to actually click this circle button up here which runs the analysis, and we get back, in this case, 120 results. Now these analyzers, this is currently what we've written. Some are in flux, some do more than others do. We've got, we're looking for error messages, insecure cookies, the low-hanging fruit, what's currently out there. We're analyzing some redirects to see if there is more information behind a redirect than is actually displayed to the browser. Your browser takes a redirect and just takes you to the next page, but I've seen applications where people actually allow you to spider the admin section because the developers didn't write the redirect portion of the application correctly. Timing analysis.
Yeah, thanks a lot, PHP developers.
Yeah, you're right on, man. The timing analysis, looking for the denial of service pages, anything that would cause the server itself to spin longer and to take up more cycles so we could, potentially execute a denial of service attack. So these are ones that we've currently written. If you've got other ideas for what can be implemented, let us know. We did implement simple regex and strings. So all you have to do is change the configuration, add your regular expression that you want to look for in all of these requests, and it'll display them to you. So currently I think we've got, we're looking for personal information. So in Altera Mutual, it found some private information here, a phone number, and it'll actually tell us, let's see, in the response, I believe. Yeah, so it finds the phone number and it'll show it to you, so it's easy to scope through there. And I think when we were building this, we decided, hey, we want to know if XSS has been found. It took us all of 20 minutes to write the XSS finder to see if an alert box popped, and if it did, then if it was in the request, then XSS is obviously within the application. So, and we'll do an example of that in just a minute. Yeah, so that's the analysis engine. Jump back over to Keynote.
So a little bit about our smart testing components, because we basically so far we've been talking about data you've already collected. So now you've already collected the data, you want to do some additional testing based on the data you've collected. So we created a requester and a fuzzer, and those are templatized, and we'll get into those in a second. We're about to do the demo. But we also have the ability to run sequences. So you can launch the sequence builder, build your sequence out, and then import it into, or just select it from the drop-down box when you're doing your testing. And of course, we have a browser object, so that browser object can be utilized during the testing as well. Oops. Oh, yeah. So this templating approach is probably better just to show you versus explain about it. So we'll go through a simple example of using the templated approach to fuzzing. So we're going to grab our URL here, make a request for the resource.
So we want to actually replay this request first. So we're just using the the OWASP broken web application. We know that this is vulnerable to XSS, so it's a good place to test.
Yeah, and we're using our own built-in web browser, so any of the requests that you make through here end up in your data set automatically.
So here's the request that I just made, the name equals test. Easy enough to send that over to the web fuzzer.
And as you can see the templates here, so there's some automatic templates, but there's a payload drop-down box for where you want the payload to go. And here's the mapping screen. So you can map payload names to different sources. Yes, the two in there are hard-coded. That will not be hard-coded for long. We needed something for the demo. So we'll have a directory where you can load all your favorite lists, and those will be automatically available to you in the interface. So go ahead.
Yeah, so in this case, I need to fuzz the name equals test variable. So I'll add the marker just there at the end of the URL.
This will be explained better in our documentation, so because we're working this out right now. So
our copious documentation at this point.
yes.
All right, so all we have to do is start the attack. You see it went really quick. Again, these are hard-coded lists. We have, it's not everything and anything. But you can actually view the results, what it did, all of them that it sent. So if we're looking at, let's see, yeah. So you can look at each of them separately, or we can go back and look at them in the response view. Now at this point, we've done these tests. We want to see if it found any XSS, so we're going to run the analyzer again. And now we have, instead of 120 results from the first run that we did, we've got 162. And all those are in the XSS finder. And it looks like we've got a couple here. If I actually render the page and it was successful, I get the XSS pop-up because I am rendering it. I mean, we're actually running the WebKit engine behind the scenes.
Okay, so we're going to have a sequence fuzzer, and we were looking at his laptop. It's kind of funny because it locked on us, so we don't know where we are. So we're going to have a sequence fuzzer, and that sequence fuzzer is going to allow you to tag data in sequences. We call it dynamic data replacement. So you can import a sequence of events, tag that CSRF token, that elusive CSRF token that's making all of your requests fail. You can tag that and then place it into your payload. So now all of those previous tests that you were running that were failing will now become successful. And in the future, we're going to have the ability to do any kind of dynamic data on the DOM. So the really difficult to test applications, you'll now have visibility into doing those without having to do them by hand.
Yeah, so I'll just do a quick sequence builder demo. This is obviously not completely functional yet, but at least give you an idea, because we're still in the process of getting our dynamic data replacement features to work. So here we have a pretty typical login form. We'll just log in, foo-foo. And as that's submitting, we should start seeing cookies getting captured. And if that ever comes back, we'll see the parameters.
The network is down. Oh, wait a minute.
Yeah, the network is down. Yeah, the local network. Yeah, we're in bad shape. But you can come through here, and by default, any sort of media responses are excluded from sequences. This is where you configure the dynamic data replacement. We're going to offer the ability to run the sequence in a web browser so you can literally render the whole thing. We discussed earlier about some of the session state problems. So we offer both an in-session pattern and an out-of-session pattern so that you can figure out, well, do I have some specific request that's causing a problem? So let's see. I think log out. Log out. Yeah.
People that are leaving are going to be really upset because we're giving away free cookies.
Yeah. What am I looking for here? Log in, log out?
Is it sign out?
Yeah, it could be. No, it's log out. All right, so if you've configured other tools, sometimes it can be a pain to figure out. So we actually search through it dynamically and mark it up for you. Yep.
So how many people in here would like to search for DOM-based XSS without having to use a browser plugin or having to send your website to some application off on the web and have it test? Anybody? That should be pretty much everybody. So we have a built-in DOM fuzzer, so it's integrated into our tool so we can identify things like DOM-based cross-site scripting without you having to use another tool. We're going to do a demo of that right now.
So I have imported a couple of web pages that are, I know, vulnerable to DOM-based cross-site scripting because I wrote them. And I'll show you the response here. So if you look in the response, it just does a simple, let's zoom this out a little bit.
This resolution is
it's just killing us.
Yeah.
So it's just doing a document.write location.href, so that's going to be vulnerable in some circumstances. This one is also doing something similar. Yeah, this is doing an unescape. So if you come over, our DOM fuzzer is very basic, but it still finds stuff. So if you look at these tests, we've generated some unique script statements. Those are quite common. An alert that would go into a string if you were doing a string, and as a pattern that's going to be pretty much unique on the page. So what we'll do is we'll go through and run the fuzzer based on the oops.
That is the absolute first time that that's happened.
Yeah.
I swear. That sounds like a joke, but it is the first time it's ever done that.
Mm-hmm.
So I guess we need to fill out some bug reports ourselves.
I guess so. So what this is doing is it's taking the saved HTML data and it's loading it into an instance of WebKit, and it's setting the base URL to the modified value. So this is not making any sort of network requests at all, but it's still replaying those values and rendering it as if it was on the original site. So we should start seeing some results coming through, and we're doing a couple of matches here. The first one is high. We hook the alert box, so if we see an alert box pop up with that number in there, we say, bang, found some DOM-based cross-site scripting. In other cases, we're just looking for pattern matches in the rendered DOM content. So like if we look at this guy, you can see that's written out, and if we render it, boom, right there. So we found DOM-based cross-site scripting without sending any network traffic at all. And are we?
Run the top slides.
Yeah. Okay. So this we have screenshots of in our presentation, but I'm going to try it. If this works.
Uh-oh.
Yeah. I'm not sure.
So
if it's
one thing
work.
tools don't normally do is give you visibility into things like SSO or LSOs and allow you to modify those to test to see what would happen.
Yeah. This is kind of a twitchy one. So the HTML5 demos, if I look at this and render it, so you see. If you come over here, you should see the local storage now has a value in it. Yep. So if we set that, and this is the part that doesn't always work.
You're not supposed to tell them that.
Yeah, well, like we said, this is still kind of a work in progress.
But think, no other tool allows you to do this. So being the only one that, and it kind of sucks right now, is better than being like,
Yeah. Yep. And I think
You may disagree, and that's okay.
Yeah, that didn't work. So we'll switch back over. What happens is it gets cached. The browser's caching that local storage reference in. We're directly modifying it through SQLite, so you don't get to see it. So here's the way it actually should look.
Here's the time that it did work.
Yeah. It works every time. You just have to restart it, which is annoying. So you modify the value, and then when you go back and re-render the page, you get the pop-up box. So that's actually modifying the local storage. And some people asked us, well, what is the attack scenario there? And we said, well, it's really no different than any other situation where one part of an application accepts data and it doesn't properly sanitize it. And then it gets replayed later. So let's say you have a web page that's storing some sort of user preference in a client-side storage. I mean, developers are starting to use this and not even realize it. Like they're importing JStorage and using it without understanding where these values are actually being stored. And then later you come back and it pulls it out of there and it doesn't encode it or sanitize it. And then you have cross-site scripting. So let's say you do some sort of forced browsing to send the value to that web page and get it saved, and then force the user to re-render that page, and they themselves find out to be vulnerable.
So we have some more slides and we have no more time. So what we're going to do is, as far as documentation goes, there's some on the project page as well as our slides. And a copy of these slides is already available on our project page. So if you have any questions, now's the time to ask them. We're actually going to be in the Q&A room as well, so we can actually go through some of the stuff we weren't able to cover. So thank you for coming out. We hope you use the tool. Please submit bug reports. Please submit feature requests. We had some people come up to us and say that they don't code, but they'd like to help out. Well, we need people to submit bug reports and help us with documentation.
Yeah, write docs, please.
Oh, and we aren't an inspection proxy.
Yeah. Thanks.